Welcome to the support class for Math 21. Let's go over some interesting questions. The following refer to the following data set. The first question that we have is, what is the arithmetic mean of this data set? So we're looking for the average. The formula for the average is x bar equals the summation of x divided by n. Now, in order to figure out the average, we have to find the sample size. In our case, if you count it carefully, there are 10 data values in our sample. And so we are going to add up all of the values and then divide by 10 to find our average. So we'll add 53.1 plus 79.6. And then we will finally divide by 10. Let's type the numerator in our calculator. And please check your work with me. Make sure you have the same number, 792 for the numerator, divided by 10. And this is equivalent to 79.2. So the average is 79.2. Let's look at the second part of the question. What is the median of the data set? In order to do this one, we have to make sure it's in order from smallest to biggest. So let's organize the data set from smallest to biggest. 53.1 is the smallest. 61.8 is next. 62.2. 72. 78.2. 79.6, 85.4, 99.9, 99.9, and 99.9. That's all 10 data values. Now we can find the number that's right in the middle. And if you look very carefully, there's two numbers in the middle. 78.2 and 79.6. To find the median, we're going to have to take the average since there's two in the middle. So we'll add 78.2 plus 79.6 and then divide that by 2 to find our median. And so the median is 78.9. What is the mode? The mode is the most common occurring value in the data set. That is an easy question. The mode is the most common occurring value in the data set, and we clearly see that 99.9 appears 3 times, and that's the most common quantity. For the last question, we're looking for the mid-range. The mid-range is the lowest value plus the highest value in the data set divided by 2. So we'll look at our data set. The lowest value is 53.1 and the highest value we know is 99.9. This is the lowest and this is the highest. So the mid-range is equal to 53.1 plus 99.9 and we'll divide it by 2. This gives us 76.5. This is our mid-range. Let's look at question number 2 now, the good stuff. Find the mean, median, population standard deviation, and range of the data set below. Let's calculate the mean. And we're considering this a population, so I'll use a different symbol. For the mean, we'll use the symbol mu. This is for the population. The population mean is equal to the summation of all the values divided by the population size. And here, we're not going to use small n, we're going to actually use big N because this refers to the population size. we have, in this case, there are 5 elements in our population. 1, 2, 3, 4, 5. And now we'll find the population mean. We'll take 18 plus 8 plus 9 plus 17 plus 1 and divide that by 5. The mean is equal to 53 divided by 5. And now we can simplify our mean. This is 10.6. The average is 10.6 for our population. And now we need to find the median. The median is, of course, the middle number. And I'll arrange it from smallest to biggest again. 1, 8, 9, 17, 18. The middle number is just 9. The median is 9. Now to find the population standard deviation. There are 2 formulas we can choose from. I'm going to choose the formula that I think is easiest. The formula for the population standard deviation, sigma is equal to the square root of the summation of x squared minus the summation of x quantity squared divided by big N, and inside the radic N we also divide it again by big N. Now to do this we should make a table, so let's make a table. On the left side I want to put x, on the right I'm going to put x squared. And so we'll list our data values 18, 8, 9, 17, and 1. On the right we'll square each of the terms. 18 squared is 324, 8 squared is 64, 9 squared is 81, 17 squared is 289, and 1 squared is just 1. Now I'm going to add the left side up, and that will give me my total for the x. And so our total is 53 here, and we'll add the total for the x squared column. And the total here is 759. This represents the total or the summation of x. This represents the summation of x squared, or the total of all the x squareds. So let's plug it into the formula. We have the square root. The summation of x squared, we know what that is. That's 759. So we'll plug in 759 minus the summation of x, which is 53. We're going to have to square that. Divide that by n. Remember, n is the population size, which is 5. And divide the whole thing again by 5. I'm going to do this portion on a calculator first. And that gives me negative 561.8, because there was a negative symbol in the front. And then I'm going to divide that by 5. So let's simplify the numerator now. We'll simplify the numerator now. 759 minus 561.8. That gives us the top, which is 971.2, and then we'll divide that by 5 again. I have this as 39.44. Now, a lot of people do the standard deviation right away. That's fine. I would recommend, if the question asks for variance, to do that first. To calculate the variance is just the square of this. So if I square both sides, I would get 39.44 for my variance, which is sigma squared. So if they ask for the variance, do it right here, square both sides, and whatever's in the radical is your variance. To calculate our standard deviation, we're going to use a calculator, and we'll round that number. Take the square root of 39.44. My population standard deviation is 6.280. Again, our population standard deviation is 6.280. Our variance is 39.44. If you were to square this to get your variance, your number would be different. So it's always best to find the variance first, then you can take the square root of whatever this is to find your standard deviation. Question number 3. A sample was done. Collecting the data below, calculate the standard deviation to 1 decimal place. In this case, we're treating it as a sample, so I want to use the formula for the sample. Let's write down the correct formula for the sample standard deviation. This is equivalent to the square root of the summation of x squared minus the summation of x quantity squared divided by n, and this is small n, and we're going to divide this by n minus 1. So there's a slight difference in the formula. Make sure you notice that this is a small n and not a big N. Because we're treating this as a sample, the sample size is 5. So let's make a table again with these values. On the left, we're going to put 4, 24, 20, 30, and 12. So on the right, we'll have our x squareds. That's 16. 4 squared is 16. 24 squared is 576. 20 squared is 400. 30 squared is 900. 12 squared is 144. Now I'll have to find the summation of x and the summation of x squared. On the left, I have the summation is 90. On the right, I have the summation is 2036. Please double check my work, make sure everything's right. And now we can use the formula to find our sample standard deviation. We have s is equal to the square root of the summation of x squared, which is 2036. We're going to plug in the summation of x, which I know that's 90. The sample size is 5, and we'll divide the whole thing by 5 minus 1. I like to simplify this part first because it has an exponent in it, and then I will divide by 5. We have s is equal to the square root of 2036 minus 1620 divided by 5 minus 1, we'll just say that's 4. Now we have s is equal to, I can simplify the numerator now, and that is just 416. Divide that by 4. S is equal to 104. Again, if I want to find the variance, I'll just write the variance is 104, and I'm done. If they ask for it, make sure you do this first. But we're just going to look for our standard deviation, so let's take the square root of 104. We'll take the square root of 104, and that's approximately 10.2, and that's our standard deviation. And if you have any questions, feel free to ask me, send me an email.